All right, so when we left off in the last videos, we just filled in the unit circle, right? We talked about the coordinates for each of the special angles. And the purpose behind this is to be able to look, or to be able to think through and just know that immediately the sine of 30 degrees is 1/2, right? We want to know those values that quickly. The other angle measures the sine of those. For example, if we came up with an angle here, those coordinates would not be as pretty and easy to remember. So that's the reason why we focus on these specials, okay? So we want to try to find a way to remember where all these coordinates are, what all these coordinates are for all the different angles. And so there are some things that you can pull out of this. For me, it's thinking about where the angle is in relationship to a quadrantal, and if I'm going more x or more y, right? So like I was saying before, for the 30-degree angle, your point ends up right here. That is more in the x direction than in the y direction. So the x coordinate is, of course, going to be bigger. So that's why we go radical 3 over 2 for the x and 1/2 for the y, because radical 3 is bigger than 1. 45 degrees lands you here. That's exactly in the middle of that quadrant. So you're not going to be more x or more y. So your coordinates are going to be radical 2 over 2, radical 2 over 2, and so on and so forth, right? And sines, we got to watch our sines, in terms of our trig values and stuff. So we'll continue to work on this and develop ways to remember all these different values, okay? All right, so the idea here is to evaluate sine, cosine, and tangent of pi over 4, right? Pi over 4, if you wanted to, you could always convert that over into degrees, right? 180 over 4 would get you 45. So you're talking about the 45-degree angle. 45-degree angle is right in the middle of quadrant 1, so I know that my coordinates are radical 2 over 2, radical 2 over 2, right? But we need sine, cosine, and tangent. So we need to back up for a second and go back to the unit circle. If the unit circle, the radius is 1, then let's back all the way up to this idea right here, right? Where sine of an angle is just the y coordinate divided by the radius, right? Y over r. Cosine's x over r, and you see the rest of them there. Well, if the radius is just 1, right, then all of these r's become 1. And so what that means is that sine theta is just the y coordinate in the unit circle. Cosine theta is just the x coordinate in the unit circle. And tangent is still going to be the y coordinate over the x coordinate. Okay? So we use that and our unit circle to understand that for the 30-degree angle, cosine of 30 is radical 3 over 2. That's how I could come up with these so quickly before. Right? Because cosine and sine are just going to be the x coordinate and the y coordinate of the point on the terminal side, right? So if pi over 4 is the 45-degree angle, right, then that means cosine of pi over 4 is just going to be the x coordinate, so radical 2 over 2. Sine of pi over 4 is just going to be the y coordinate, radical 2 over 2. Okay? 5 pi over 3, right? So 5 pi over 3, again, if you wanted to, you could convert that into a degree measure. And so it's going to give you 300 degrees. 300 degrees is just 30 degrees from 270. So you're talking about being in quadrant 4, and it's that first spoke in quadrant 4, right? 5 pi over 3 is sitting right here. So if you want cosine, it's 1/2. If you want sine, it's negative radical 3 over 2. That's the idea behind using this unit circle. Sine theta is negative radical 3 over 2. Right? So have your unit circle out and continue to try to think your way around that. And we'll keep talking about different ways to try to remember the coordinates. Right? You'll develop the way that makes sense, the most sense to you. All right? Okay. Now, even and odd trig functions. Some of these guys are even, and some of these guys are odd. Okay? And what we mean by that, cosine and secant functions are even. That's because the cosine of a negative angle is equal to the cosine of the positive angle. They're going to be the same. And since secant is the reciprocal of cosine, hopefully it makes sense that's going to be an even function also. But that's what it means to be an even function. If the cosine of the negative angle is the same as the cosine of the positive angle, then that's going to be an even function, right? If we go back to our unit circle, pick an angle. And I'll keep using the 30-degree angle because it's right there, it's easiest, right? Cosine of 30 degrees is radical 3 over 2. Cosine of negative 30, now remember you have to go in the clockwise direction. Cosine of negative 30 is the same thing as cosine of 330. That's also radical 3 over 2. So that's what makes that even. Cosine and secant are even. So it doesn't matter which direction you go, clockwise or counterclockwise, cosine is going to be the same. Sine, the rest of them are odd. The rest of them, that means that the sine of a negative angle is equal to the negative sine of the positive angle, right? And we can see that in our unit circle as well. Go back to 30, angle 30, right? Sine of negative 30, which is this way, is negative 1/2, right? Sine of negative 30 is negative 1/2. If we go to, so that's going to be the same as the negative sine of 30, which is negative 1/2. Okay? Does that make sense? And so we can kind of use that idea as well, right? So sine 5 pi over 6. Evaluate the trig functions using the unit circle for part A and even odd properties for part B. Okay? So in other words, in A here, sine of 5 pi over 6. We go back to our unit circle, 5 pi over 6. And we're going to have to start developing the idea that all of these angles whose denominators, radians denominators are 6, talked about this before, have the same coordinates. It's just that their signs are different, right? 5 pi over 6 is a radians of over 6, so our coordinates are going to be radical 3 over 2 and 1/2. But 5 pi over 6 is in quadrant 2 because it's just less than 1 full pi. So that means if we're in quadrant 2, the x has to be negative, the y has to be positive. So our coordinates are negative radical 3 over 2 and 1/2. So if we want sine of that, then that's just going to be positive 1/2. Right? If we want to know the sine of negative 5 pi over 6, then it's the same thing as finding the negative of sine 5 pi over 6. And we just found 5 pi over 6, which is 1/2. So it's going to be negative 1/2. Okay? Tangent of 11 pi over 6. Again, our denominator is 6. That means our coordinates are going to be radical 3 over 2 and 1/2. Now, 11 pi over 6 is just short of 2 pi. That's going to put us in quadrant 4. Since it's going to put us in quadrant 4, then our y coordinate is going to be negative. Right? So that means that tangent is just going to be the y over the x. And now we've got to flip this guy over, so negative 1/2 times 2 over radical 3, divide those out. We get negative 1 over radical 3, and then rationalize. So we end up with negative radical 3 over 3. It's kind of crazy. Okay? Tangent is another odd function. So that means that the tangent of negative 11 pi over 6 is the same thing as negative tangent of 11 pi over 6. And we just found the tangent of 11 pi over 6. So all we do is we multiply it by a negative 1. So it's just radical 3 over 3. Okay? So a way we can use even and odd. All right. Some review. Find two coterminal angles, one positive, one negative, for each angle. For each of these, take a couple seconds, stop the video, try to come up with those the answer, and then start it back up and see if you're right. All right, so if we want a positive coterminal angle, then we want to add 2 pi here, which is going to be the same as adding 30 over 15 pi, which is 28 over 15 pi. Then we can subtract. Which is the same as subtracting 30 over 15 pi, which gets us negative 32 pi over 15. So there are your two coterminal angles. Stop the video and try B. Okay, so we're adding 2 pi here, which is the same thing as adding 24 over 12 pi, which is 35 pi over 12. And then we want to subtract 2 pi. So now I'm going to subtract 11 minus 24 and get negative 13 pi over 12. Okay? Sketch each angle in standard position. Again, stop the video and try A and B. Once you've got them both, start it back up and see if you're right. Okay, for 4, remember it's not a radian. We have to sort of figure out, in terms of pi, our quadrantals, right? So since this is pi, this is 3.14. This is 2 pi, so this is 6.28. Now take half a pi, and that'll be your positive y-axis. This is 1.57. And then for this last guy, go 3 times pi divided by 2, and you get 4.71. So if we're at 4, then our angle in standard position would start here and end up about here. It's going to be more than 3, but less than 4. Okay? 7 pi. If I go around once, that's 2 pi. Twice, that's 3 pi. 3, that's 6 pi. Sorry, 2 pi, 4 pi, 6 pi. And then I have to go around half a time to get to 7 pi. So my angle is going to look something like this. Okay? And the last two. What quadrant does each angle lie in? Stop the video, give it a shot, and see if you come up with the right answer. Okay, since as a mixed number, this is 1 3/8. That means I have gone 1 pi, and then I need 3/8 more. 3/8 is less than a half, so we're going to be in quadrant 3. Okay. 13/8 is 1 5/8 as a mixed number. So it's kind of the same thing where we're going to go around a pi, and then 5/8 is more than a half. So I want to go past this half. And so we're going to end up in quadrant 4. Okay? All right, there you go. Try the homework, and we'll fight through any questions next time.